Hello students, welcome everyone. Welcome to your favorite channel Vedantu NCERT Solution, where you will get a detailed description of each and every NCERT questions, and we are going to solve and explain you so that you understand and score better in your examination. Now we are going to solve question number 10 of your exercise 1.1 of the chapter relation and function. Give an example of a relation. We have 5 sub questions here, and see children, they are asking you to give an example of relation which is symmetric but neither reflexive nor transitive. That is the first sub question. Second one, transitive but neither reflexive nor symmetric. Second sub question. Third one, reflexive and symmetric but not transitive. Fourth sub question, reflexive and transitive but not symmetric. Fifth one, symmetric and transitive but not reflexive. Let us try to write an example for each of this one by one. See children, you can make use of the examples which you have already solved, because the question from 1 to 10 has some examples, or there are some questions where it is symmetric but not reflexive and transitive, or it is transitive neither reflexive and symmetric, like that. So you can take those examples and write, or you can give some additional examples. But now let us take some unique examples so that you can understand the concept better. Now let us try to solve first sub question. Okay, let us try to write an example for a relation which is symmetric but neither reflexive nor transitive. I will take a set A. I will take set A as 1, 2 and 3. Okay, I will take set as 1, 2 and 3, and my relation R will be 2, 3 and 3, 2. I'll take this as my relation 2, 3 and 3, 2. Now see children, in this relation, you can notice first, if I'm checking for reflexive relation, whether it is reflexive, just check sir, it will not be reflexive because you don't have 1, 1, 2, 2 and 3, 3. So let us write 1, 1, 2, 2, 3, 3 does not belong to R, right children? So hence not reflexive. Over, it is not reflexive. Now check for symmetric children. Is it possible to tell it is symmetric? Yes, because sir, the elements what you have taken for symmetric condition, it is valid here. Why? Because symmetric condition tells that A comma B, if it is present in R, B comma A also should be present. So you can notice 2 3 belongs to R and 3 2 also belongs to R, right children? So in that case it is symmetric. So this is an example where it is symmetric but not reflexive. And let us check for transitive. It is symmetric, right children? Yes. Now let us try to write an example where it is it transitive? Let's check children. Yes, can we check whether it is transitive here? Yes, because we have not checked the third condition. Now observe this. Here 2 3 is present, but you don't have any other element, right children? 3 2 is also present, but you don't have any other element, like you don't have 1 3 does not belong to R. Hence what you can write, not transitive. I will write not transitive. So easily we have written an example where the relation is symmetric. It is symmetric but neither reflexive nor transitive. I hope this is clear children, easy and simple. Now let us go for the second one. See, second one, when you're writing, I want my children to be very careful when you're writing such question, because it is very, very important. Such question may come in your examination, but anywhere if it is asked, you should be in a position to answer them, because they are asking you to give an example where it is transitive but neither reflexive nor symmetric. So observe here very carefully. I will take a relation R for all the set of natural numbers. A comma B belongs to set of natural numbers. Let us take it that way. Okay. Now A is greater than B. I'll take this condition. If you consider this condition children, observe it very carefully. It cannot be reflexive. It cannot be symmetric. Why? Tell me. If A greater than B, then A comma B belongs to R. True children? Set of natural number I have taken, counting numbers basically. So you can write A comma B belongs to set of natural numbers. Yes. Now A greater than B, A comma B belongs to R. So A comma A can never belong to R, because A can never be greater than A. So I can write it does not belong to R. Hence R is, this relation is not reflexive, right children? Easy and simple. Yes. Now, R is not reflexive, we got it. Now, let us check for the condition of symmetry. As I told you, if A is greater than B, children, can B, again you can write B greater than A, not possible. If A greater than B, so A comma B will belong to R. In that case, B comma A can never belong to R, right children? Yes. So it is not symmetry, right? Yes, this is possible. Now, let us check for the next condition. Now, we will check for the condition transitive. Just observe here children, very important, the last step. Now, let me take A comma B belong to R. In that condition, you need to remember A is greater than B. Okay? Yes, sir, it's possible. Now, you can write B greater than C, or you can write B comma C belongs to R. Possible children, that means B is greater than C. Now see, think about this condition. A is greater than B and B is greater than C. Now what is the relation between your A and C? Can you tell me children? What is the condition here? B greater than C. Okay? B greater than C. Now in that case, is it possible to write A comma C belong to R? Yes sir, it is possible, because if A is greater than B and B is greater than C, obviously A should be greater than C children, right? A should be greater than C here, correct? A should be greater than C. Let us write C little more neatly. Okay, so A should be greater than C. In that case, what is this relation? What is this relation? This relation is transitive. Observe, when you take A greater than B condition, it is neither reflexive nor symmetric, but it is only transitive. So I will write it is transitive. Yes children, understood this? I hope this is easy and clear for all of you. Yes, we have already solved second sub question. Now let us try to solve the third sub question. Okay, reflexive and symmetric, but not transitive. Okay, it should be reflexive and it should be symmetric, but it should not be transitive. So let us try to solve this case now. Just observe here children. In that case, when you are solving for reflexive but not symmetric and transitive, one easy thing, let me tell you what you are going to take. Let me take A as a set. Just observe here, they have given reflexive and symmetric, sorry, reflexive and symmetric but not transitive. So let us take a set A which contains element 5, 6, 7. Okay, like I've taken in the first question. Let me write this R as, I will write 5 comma 5, 6 comma 6, 7 comma 7, okay, 5 comma 6, 6 comma 5, and I will write 6 comma 7, 7 comma 6. Let's close. I am not relating with three elements at all here, because I want to give an example where it is not transitive. So is it reflexive? Yes sir, it is reflexive, because all what we needed is present, right children? It is reflexive. Why? What is the reason you're going to write? It is reflexive because we have 5 comma 5, 6 comma 6, 7 comma 7, which belongs to R. Yes, so 5 comma 5, 6 comma 6, 7 comma 7, all these belong to R. Yes children, so hence it is, what do we write? Hence reflexive. Yes, now tell me about symmetry condition. It is symmetric sir. Why? What is the reason? Symmetric, what are the conditions children? Whatever needs to be clarified, that is there here, because 5 comma 6 is there, 6 comma 5 is there, 6 comma 7, 7 comma 6 is there. So you can write for every I'll write for every A comma B belongs to R. Here A comma B and B comma A also belongs to R for every case, correct? So hence it is symmetric. It is symmetric, right? Symmetric. Yes. Now tell me the next case where it is transitive. Now if you're writing transitive, what happens? Three cases, A, B, C. But observe here children, you have 5 comma 6, okay, that belongs to R, and you also have 6 comma 7, that also belongs to R. But do you have 5 comma 7? No sir, 5 comma 7 does not belong to R. So this is not transitive, right children? It is not transitive. So this is an example where it is reflexive and symmetric but not transitive. I hope my children are clear with this. Yes, the third sub question where they asked us to find or to write an example where it is reflexive and symmetric but not transitive. I hope this is clear children. Yes, we have already solved the third sub question. The first one was done, it was clear. Second one was done, third one is also clear. Now let us try to solve the fourth sub question. Now observe here children, in the fourth sub question they're telling you the relation should be reflexive and transitive but not symmetry. It should be reflexive and transitive but not symmetry. Try to understand. Now we'll take some unique relation to prove that. You need to keep it in mind children. Just observe here. I will take this relation as a relation for a set of natural numbers again, because most of the time when you take natural numbers it is easy for you to prove. So now I'll take set of natural number where a cube is greater than or equal to b cube. I'll write. Yes, why I have taken this unique relation, let me tell you. Clearly a comma a will belong to our children. So directly you can write reflexive because equal to symbol is there. Yes, so that is the reason I have taken this example. It is reflexive, right? Now check for symmetry. Is it symmetric? Yes, check for symmetric condition. Is it symmetric? Tell me. So here if you check, for every a comma b belongs to R, okay, if it is not equal it should be greater, right children? B comma a also belongs to R. Is that true? Yes or no? Because if you write 1 comma 2 belongs to R, that means 1 cube is greater than or equal to 2 cube. You need to write it is it greater than or equal to? Yes, tell me. Can it be greater than or equal to? No. Here 2 greater than or equal to 1. So 1 greater than or equal to not possible. If 2 greater than or equal to possible, right? So in that case what do you write? It is not symmetric. It is not symmetric, right children? Because what are they asking here? They are asking us it should be reflexive and transitive but not symmetric, but this is not symmetric, right? Now just observe here the third case, transitive. It is transitive children. Yes, think and tell me, if you take 3 elements or if you take 3 numbers which belongs to set of natural numbers, suppose take an example, a cube will be greater than or equal to b cube. In that case, if b cube is greater than or equal to c cube, then obviously a cube should be equal to greater than equal to c cube. No, right children? True? Correct? No? So in that case what you can write? It is transitive. So this is a typical example, okay, for a relation which is not symmetric but reflexive and transitive. I hope this is clear children. It was easy and simple. Yes. So here we have solved the fourth sub question where it is reflexive and transitive but not symmetric. I hope this is clear for all of you. Yes. Now let us try to solve the last sub question, and my children will be able to solve this because they already have seen a lot of examples. Symmetric and transitive, not reflexive. So take the set children. Can you tell me what we can do? We can do now, let a equal to, let us take a set. I will take a set -5 -6. There is a reason why I'm taking this. Let me tell you, there is a reason why I'm taking this set. Observe, I will write the relation set R as -5 comma -6. Okay, I will write this, then -6 comma -5 also, and I will write -5 comma -5. Okay, just try to observe why I have written this. Let me tell you, it is obviously not reflexive because -6 comma 6 does not belong to R. So you can write it is not reflexive. That is the reason I have not included that term -6 comma 6. It is not reflexive, right children? Because if it is a reflexive, for every value of a comma a should be possible. Correct. Here it is does not belong. Now check for symmetry condition children. It is symmetric. It is symmetric. What is the reason it is symmetric children? Yes, it is symmetric. Now what is the reason? Tell me. If you're checking for symmetry condition, it is symmetric. The reason is for every a comma b belongs to R, b comma a also belongs to R. True. because if you notice here, minus 5 comma 6, minus 5 comma minus 6 belongs to R, and minus 6 comma minus 5 also belongs to R. So it is symmetric. Now tell me about transitive, children. What happens here? Transitive. Is it transitive? Is this relation transitive? Yes. Now if you try to understand, it is transitive. The reason is, just observe here, minus 5 comma 6 belongs to R. Okay, sir, correct. Minus 6 comma minus 5 also belongs to R. After that, if you consider that minus 5 comma 5 as an element, you also have minus 5 comma 5 which belongs to R. Correct? No. Does it satisfy? Yes. So it is, what do you write? It is transitive. Right, children? It is transitive. So it is reflexive, not reflexive, symmetric and transitive. That means it is transitive and symmetric, not reflexive. This is the last question under question number 10 of your exercise 1.1. So you have seen all the examples where it is symmetric but neither reflexive nor transitive, transitive but neither reflexive nor symmetry, reflexive and transitive, reflexive and symmetry not transitive, reflexive and transitive not symmetry, symmetry and transitive not reflexive. We have seen all these examples. See, children, as you go on solving the problems, you can directly take some of the questions directly and solve if you're thinking that it will take a lot of time, but try to solve a unique example so that concepts will be very clear to you. I hope all of you understood. Like, share and subscribe, share it with your friends so that even they can clarify all their doubts and solve more and more NCERT questions easily and quickly.